We're going to take a look at problem 6 now in that optimization packet. Take a moment and read through the problem. I want to find the maximum volume, so that's going to be my primary equation. Volume of this box is going to be the length times the width times the height. That's x times h. My primary equation is v equals x squared times h. As for a secondary equation, I'm told that the surface area of this box is 108 square inches. That's going to include the front, the back, the left, the right, the bottom, but not the top because it's an open box. So I think that I can say, let's see, each of the front, back, and left and right sides will be x times h. And there are 4 of those. And then I have the bottom that's x squared. So 4xh plus x squared is going to equal 108. Let's see, let's go and solve this thing for h, so I can plug it in over there. I'm going to get 4xh equals 108 minus x squared. I'm going to divide everything by 4x, so h equals 108 minus x squared over 4x. And let me try to do some simplifying here. I'll go and separate my fraction. So 108 divided by 4x minus x squared divided by 4x. This is going to give me h equals 27 over x minus x over 4, which doesn't look so great, but I think in the end it'll work out okay. Plugging this into my volume formula, we're going to get v equals x squared times 27 over x minus x over 4. I'm going to go and distribute the x squared, so 27x squared over x minus x cubed over 4. This is going to give me 27x minus x cubed over 4. That's the thing that I want to maximize. As for the domain, this is going to be a pain. I know that x has to be positive. Surface area is 108. You know what? Forget about this. Let's just say that I know x is greater than or equal to 0, and rather than using the Canada's test, I'm going to try to use that global justification that we talked about in class. Okay, so I'm going to go and I'm going to find my derivative. I'm going to get 27 minus 3/4 x squared. And now I need to find my critical values, so I'm going to set that equal to 0. 27 equals 3/4 x squared. I'm going to multiply by 4. 108, I believe, equals 3x squared. Divide by 3. It's maybe not 108. Hold on. Maybe I did that wrong. Yeah, it is 108. Okay, and then 108 divided by 3 should give us x squared equals 36. Take the plus or minus square root. We just care about the positive one, though. Our critical value is going to be x equals 6. So now I'm going to go make my number line. So I'm going to try to use my global justification here. I'm going to put a tick mark at 6. I'm going to go and I'm going to plug in something like 1 to my first derivative. Well, I know if I plug in 1, 27 minus 3/4 is something positive, so I'm going to make that region positive. If I plug in something like 7, I'll just do it on the calculator, 27 minus 3/4 times 7 squared, negative 9.75, so that's negative. Yep, I do have a max at x equals 4, because v prime is positive everywhere before there, so v is increasing everywhere before 6, and v prime is negative everywhere after 6, so v is decreasing everywhere after 6. I'm going to state there is a max at x equals 6 because v is increasing everywhere before x equals 6. And we do need to explain why we know that, so I'm going to say because v prime is positive there. And v is decreasing everywhere after x equals 6. Again, we need a reason for that, because v prime is negative there. Okay, so I need my dimensions and then I need my volume. Well, the height is going to be 27 why don't I plug into the original height equation rather than the fraction E1? I'm going to say 108 minus 6 squared over 4 times 6. Go to the calculator. Let's get this one, and the height should be 3. So my dimensions of this box, 6 inches by 6 inches by 3 inches. We're asked for the volume. Well, we could plug into the volume formula, or really we could just multiply those dimensions together. And when you multiply them together, you're going to get 108 cubic inches. And by the way, it was a complete coincidence that the surface area of the box was 108 square inches and the volume was 108 cubic inches. No, in general, that's not going to happen.